So now that we've worked through the theory and developed the formula for the projection of one vector onto another, and also decomposing it into a parallel and perpendicular vector, we'll apply that knowledge to some questions. Our first question comes from a VCE exam, and it's asking us it's giving us two vectors, and it's asking us to express the vector as sum of two vector resolutes, one parallel to B and the other one perpendicular to B. The language you use in New South Wales for vector resolutes is the projection of vector A onto vector B. So this question is asking us to find the projection of vector A onto vector B, and then to find that perpendicular vector to give a vector sum. So we'll start with the projection of A onto B, and I'll call that vector U. So vector U, we're calling our formula, is A dot B divided by the modulus of B squared multiplied by vector B. So let's go ahead and work out A dot B. So A dot B is equal to, multiplying out our components, 3 times 2 is 6, 2 times minus 2 is minus 4, and 1 times minus 1 is minus 1. And so we get A dot B is equal to 1. The modulus of B squared is squaring the components, 4 plus 4 plus 1, which gives us a total of 9. Our vector projection of A onto B is 1 over 9 multiplied by vector B. To write vector A as the sum of its resolute and the vector perpendicular to B, you can remember a formula, but I'd prefer to draw a diagram. So here, imagine if we have vector A, we worked out that if this was vector B, vector U is the projection of A onto B, which we've called U, which would be that vector there. Let's call the perpendicular vector W. So we can write vector A is equal to U plus W. Rearranging that, we can say that W is equal to A minus U. So vector A is 3i plus 2j plus k, and we're subtracting from that vector U. And when we calculate that, we get 25 on 9i plus 20 on 9j plus 10 on 9k. So finally, to write A as the sum of these two vectors, we could say A is equal to the projection vector first, which would be the parallel vector. So 1 on 9, 2i minus 2j minus k, plus the perpendicular vector, which is 1 on 9, and so 25i plus 20j plus 10k. The question asked us to clearly note which of the vectors was parallel and which was perpendicular to B. Our first vector here, the projection of A onto B, is the parallel vector to B, and this vector is the one that's perpendicular to B. Okay, question 2 in our vector projections. You make sure you read through the booklet first and have a go at the question, and then we can go through it together here. Okay, so question A is asking us to find an expression for vector AB. So vector AB is vector B minus A, which is I. J minus 2j is minus j, minus k is minus 2k. Vector AC is C minus A, which is equal to 2 minus 1, which is I, minus 3 minus 2 is minus 5j, and k minus k is 0. For part B, we need the resolute of AB in the direction of AC. So I'm going to label that vector U. So vector U is equal to, using our formula, AB dot AC over the modulus, over the magnitude of AC squared multiplied by vector AC. So using our dot product, we get 1 times 1, which is 1, negative 5 times negative 1, which is positive 5, and 0 for the k components, and the magnitude is 25 plus 1, this is 26, and vector AC is I minus 5j. Simplifying that is 3 on 13 I minus 5j. Question C, it might be worth drawing a diagram. Just because of my space, I'll draw it up here. We have points A, B and C. And we're looking at vector AB and AC. And we found the resolute of AB in the direction of AC, which on this diagram we called vector U, so that would be that vector there. The shortest distance is going to be the perpendicular distance from the point to the line. That distance would be represented by this vector here, which we'll call W. The vector W is equal to vector AB minus U, which is I minus J minus 2k minus 3 on 13 I minus 5j, which when we simplify that is 2 on 13 5i plus j minus 13k. So the distance from B to A is the magnitude of W. So the magnitude of W, I'll square it just to keep it simple, is 4 over 169 multiplied by these components squared, so 25 plus 1 plus 169. When we work that out, the magnitude of W, or the distance, is equal to 2 root 195 all over 13. And finally, to work out the area of the triangle ABC, it's going to be a half base times perpendicular height. Now a base is going to be the vector AC, and our perpendicular height will be the length of vector W, and so that's what we need to find the area. So the question D, the area is equal to a half times, now the magnitude of AC is square root of 26 times the magnitude of W, which we worked out was 2 root 195 all over 13. And when we simplify that, we should get our area is the square root of 30 square units. So hopefully you understand what the projection of one vector onto another is. You've learned how to use the formula, and now you've solved a couple of questions at that. In our next video, we'll be looking at applying the use of vectors to solving geometry problems.